All right, this is our last topic in our solutions unit. This is often referred to as colligative properties, but really it's just what effect does that solute have on the properties of a solvent when that solute's been dissolved into it. Because when a solute dissolves into a solvent, the particles are attracted to the particles of the solvent, so that affects the properties of our solvent. So the ones that you have to be aware of is that first off, it lowers the vapor pressure of the solvent. And when we've talked about vapor pressure, we've talked about how it's related to this idea of how well the liquid particles become a gas. The more easily that those liquid particles can become a gas, the higher the vapor pressure. Well, because the solute's attracting that solvent and kind of holding them in that liquid state a little bit more, it makes less of them go into the gas phase, so it lowers the vapor pressure. Now, the two that you guys really have to focus in on has to do with our boiling point and freezing point. Because it lowers the vapor pressure, it actually then causes the boiling point to increase. So it raises the boiling point, often called the boiling point elevation. The freezing point does the opposite, so it lowers the freezing point. So it's called freezing point depression. In honors chemistry, we actually get into the calculations of just how many degrees the boiling point goes up or the freezing point goes down. Here, we just have to understand the effect that it has on the boiling point and freezing point, and then how to differentiate which might have the biggest effect in terms of a solute. So just some background on that. We talked about how the solute gets in the way of the solvent. So in this example of sugar, you can see we have pure water and then the sugar molecules come in. Well, because the sugar interacts and attracts the water molecules, it's going to take more energy for the vapor pressure to equal that atmospheric pressure, so that relates to the elevated boiling point. And when freezing, you can think about, in order for water to freeze, those water molecules have to attract each other. Well, the sugar molecules are kind of like little obstacles in the way of that. So they have to lose extra energy, which is going to lower the freezing point when that solute's been dissolved. So the overall idea here is that the more solute particles that are in solution, the higher the boiling point is going to be and the lower the freezing point. And it's all about the amount of solute particles within it. So I use, the little alligator there, and the idea of you're increasing the boiling point, you're decreasing the freezing point. So the more particles that there are, the wider that's going to go. Okay, so the higher the boiling point's going to go and the lower the freezing point's going to go. All right, so what are some things that affect the number of solute particles? Well, obviously the concentration. So concentration we're usually dealing with in terms of molarity. Okay, the higher the concentration, the more particles there are in the solution. So the higher the boiling point and the lower the freezing point. So if you have like a 0.1 molar NaCl versus a 0.5 molar NaCl solution, and both of these would be aqueous. Okay, compared to the regular or standard boiling point and freezing point of water, we would expect both of them to have an effect, but the higher concentration, the 0.5 molar NaCl, would have that higher boiling point and then the lower freezing point because, again, there's the most amount of particles because of the higher concentration. All right, if we move on to the last little part of this is not just molarity has an effect, but also how many particles a compound will dissolve or ionize into when placed into the solvent. So this goes back to when we did bonding and we talked about electrolytes and non-electrolytes. So electrolytes are going to produce ions when they dissolve. So this would be ionic compounds, which are your metals and your nonmetals. Acids, which we haven't done yet, so you don't need to worry about. Non-electrolytes do not break up into ions, and these are your molecular compounds. So these are ones that are made up of just your nonmetals. So you have to be able to use your periodic table to distinguish between them. So the idea is that electrolytes, because they produce more ions when they dissolve, they're going to have usually a bigger effect on your boiling point and freezing point. Okay, because of that idea of they're producing more particles in your solution. So what you have to be able to do when you're going to see this in the practice is you have to identify, is your compound an electrolyte or non-electrolyte? So will it break up into more particles or just stay as one? So let's go through some of these examples. How many particles do each of the following break up into? So if we check NaCl, this is Na is a metal, chlorine is a non-metal. So we know then that this would be an electrolyte because it's an ionic compound. Okay, so that means that that would break up into ions. And not that you are going to have to be able to write this out, but just so you can see, you have your sodium ion, and then you have your chloride ion. So this breaks up into 2 ions. Okay, if we look at calcium bromide here, calcium's a metal, bromine is a nonmetal, so this is also an electrolyte because it's also ionic. However, when this one breaks up, you have your calcium ion, and then you have 2 bromide ions. So if we add these together, calcium bromide actually makes 3 particles or 3 ions. And then this is going to be kind of the one that always catches students. Carbon, hydrogen, oxygen are all nonmetals. So because they're all nonmetals, you have a molecular compound, which means this is a non-electrolyte. So even though it looks like there's a lot of atoms there, they stay together as a molecular compound. So this will actually stay together as that C6H12O6. So there's only one particle here. Okay, so it says if each of the 3 compounds above were used to create a 1 molar solution, which would have the highest boiling point, you'd have to look through all the formulas. You'd have to see that the calcium bromide produces the most amount in solution, so it has to be your calcium bromide here. Okay, ones to just be on the lookout for would be polyatomic ions. So say you had something like Li2CO3. Because that one has a polyatomic ion on table E, that group is going to stick together. So when you look at how many this breaks up into, this would be 2 lithium, and then that carbonate actually will stay together. So for this lithium carbonate, this is going to break up into 3 ions. So just be careful with table E, keep those together as a single group. All right, so again, just to kind of summarize everything, you're going to be looking at molarities, and you're going to be looking at the type of compound when needed. And the big idea is that, again, the more particles a solute breaks up into, the higher the boiling point is going to be and the lower the freezing point. All right, make sure for this one you go through the practice before getting on the quizzes today, just so that you can kind of start to understand how these are going to break apart and then test yourself at the end.